Okay, so so till now what we have discussed the relationship between regular expression, regular languages, finite automata, right? And regular grammar, right? That we have discussed, that we already have discussed in a lot of time. We have started recording a little late today. Second thing we are discussing today, identities of regular expression. In that, we have talked about these operators. This also we have discussed a little in previous class also, that we have four types of operator in regular expression, that is union, concatenation, lean closure, and plus closure, right? So union is being represented by this plus, right? We can also call it or, and this concatenation is represented by this dot. We can also call it and. This lean closure is being represented as power star. It is also called zero or more time. And this plus closure is represented by power plus. We can also call one or more time, right? That is the meaning of this. Now we are talking about the precedence of these operators. So the highest precedence, like in mathematics, arithmetic expression, we have BODMAS, which is talking about the precedence. Here, the highest precedence is of these closures, lean closure and plus closure, right? Star closure and plus closure, you can also call it, right? Second is concatenation, right? Third priority is for union. Third and last priority, you can say, for union. So union is having a least priority and concatenation is having a highest priority. So whatever regular expression we will get, we will first perform concatenation and then we will perform first we will perform the closure, then we will perform concatenation, and then we will perform union, right? Okay, so this will be the sequence, the precedence of these operators, right? Okay, so having said all these, now let us talk about identities of regular expression, right? Identities. Identities of regular expression. Okay, now let us try to understand every identity in a little detail, and that will be quite helpful in conversion of regular expression and finite automata. So let us see one by one. So first is, if we have something called phi means nothing, right? There is nothing. There is a difference between phi and epsilon. That's why I'm taking this topic, right? So that you understand the difference between phi and epsilon. So phi plus any union uh, with any regular expression. So here R1, R2, whatever I will write, that is a regular expression, right? So make it a note. So R1, R2, all these are regular expressions. A regular expression can be anything, right? A regular expression can be a phi, can be an epsilon, can be a input symbol, can be combination of input symbol using these operators, right? So anything is regular expression. All these are regular expressions, right? So what is a regular expression? All these. The elementary one are epsilon, phi, and the all input symbol a, b, whatever. These are also regular expressions, right? 0, 1, whatever is the input symbol. Then we use these operators in making derived regular expressions. All these are regular expressions. Okay. So wherever I will write r here, that will simply mean a regular expression, right? Okay. Fine. So the first identity is, if we do the ORing with phi, then it will be R only. So phi plus R is R, right? So if you do or means or with phi means nothing, that will give the same language. That will give the same regular expression. That is the first identity. If you apply lean closure on epsilon, epsilon means zero, epsilon means nothing, right? Epsilon means empty transition. Phi means nothing. Epsilon means empty transition. You remember the finite automata if you have any doubt. So if we have a finite automata like this, right? There is no transition between input initial state and final state. This is for phi. Phi means no transition. But epsilon means what? Epsilon means if we have a empty transition. Let's say this is the initial state, and let's say this is my final state, then there is a transition on epsilon, means without even getting anything you can go to the final state. That is the meaning of epsilon. Phi means you cannot reach to the final state. You can also represent this epsilon as this. We always do that. in designing the finite automata. We said that if initial state is the final state, then epsilon is also accepted, right? We always say that. This is the meaning of this. We have designed a lot of finite automata. We understand this, right? So you can design it like this for epsilon, or you can make initial state as final state. That is also fine, right? But here in phi does not mean epsilon. You have to understand this, right? Phi means you cannot reach to final state. If I'm saying between not only final state, if between any two if between any two state I'm saying that there is a phi transition between them, that means you cannot reach from one state to another state, right? If I'm saying that transition from uh, q naught on a is phi, means what? From q naught on getting a, we are going nowhere. That is the meaning of this, right? So you should understand what is the meaning of phi. Okay, so a phi plus any regular language is that regular language only. Ep, and before moving to epsilon, if I say phi concatenation with any regular language is phi. This is very important. You have to understand this, right? Phi concatenation with any regular language, regular expression is phi only. So if you do concatenation with phi for any regular expression, then that regular expression will be, it is like zero. If you multiply anything with zero, that will become zero. If you add zero to anything, it will not affect anything. Do you understand this? The meaning of phi, right? This is the meaning of phi. Any doubt? This is important. Any doubt here? Is that clear? Hmm? Okay. Fine. Now, this is a little about phi. Now let us talk about epsilon. Epsilon closure, if you write something like this, epsilon closure, that means nothing. Epsilon zero or more times. So anytime epsilon will come, it will remain epsilon only. So epsilon closure is epsilon, right? Then phi closure. What is phi closure? This is interesting and this is very important. Phi closure means what? Phi closure means what? Phi closure means phi can come 0 time, plus phi can come 1 time, plus phi can come 2 times, any number 0 or more time. Epsilon lean closure means what? 0 or more time, right? So it can come anytime. Now phi to the power 0 is epsilon. That is the idea. And all these will be phi only, right? So phi plus epsilon will be epsilon. Phi plus, because anything plus regular expression is that regular expression. So phi epsilon is a regular expression. So epsilon plus phi will be epsilon, right? And that's why phi closure is epsilon. Phi closure is epsilon. This is very important. Phi closure is epsilon. This is also very important, right? Phi closure is not phi. Phi closure is epsilon. Do you understand why phi closure has become epsilon? Hmm? Why phi closure? Phi closure means 0 or more time. Phi can come 0 or more time. Let's say phi comes 0 time, phi come 1 time, phi come 2 time, and so on. So phi comes 0 time means what? Epsilon. So phi closure will become what? Phi closure will become epsilon plus all these will be phi, means phi only. So epsilon plus phi. Anything plus phi we have already seen. Anything, any regular expression plus phi is that regular expression. So epsilon plus phi is epsilon. So phi closure will be epsilon. Right? Is that clear? Hmm? Okay. So again, this meeting will close in next 10 minutes. So you can rejoin the same meeting. Okay. So these are the initial. So let me restart this meeting. Right. So I'm restarting the meeting. Right. You rejoin the same meeting. Then we will start our further discussion. Okay. Let me restart this meeting.